All right, today we're going to move on to section 2 of module 5. It's on congruent triangles, but we're first going to start by talking about congruent polygons in general. All right, and so congruent polygons means that all their parts are congruent. So you have congruent polygons if you have all congruent parts. All parts are congruent. And so that means, what are the parts of a polygon? You know, I have arms and legs and a head and eyes and a nose. What does a polygon have? A polygon has sides and angles. So all of the sides and angles of one polygon match the other. And so, you know, on the left here, do these two triangles, all right, do these two triangles look like they're the same? Yeah. But are they the same? Are they congruent? I can't say they're congruent until I can say all three angles match and all three sides match. And so that is what those little tick marks mean. And so now that all the parts are congruent, the polygons themselves are congruent. And so here we have to write a congruent statement and identify all the parts. And the first few in your homework are going to kind of look and work like this. And so angle A up here has one little mark by it. All right. And so angle E has one little mark by it. And so angle A matches angle E. And it's important that you look for those congruent marks because they're not always going to draw it so that it's so easy to tell. B matches with F. They're both 90. All right. G matches with C. And H matches with D. And so those are how the angles themselves match up. And now the one dash side. So this side has one dash. This side has one dash. And so AB, side AB, segment AB matches side EF or segment EF. Side BC or segment BC matches side or segment FG. Side CD or segment CD matches, now I went from C to D, and so you could probably write it either way, but it's best to get used to matching up the corresponding parts. And so we said C and G go together. And so if C's first, I want to write G first. And then DA, I want to write HE. Now, when I write this congruence statement, I have to put them in order. So because this one goes A, B, C, D, this one goes E, F, G, H, and that's because that's the parts that match up. Right? You want to be careful with that, and I'll show you an example of what I mean by that next here. And so we have two triangles. And we're going to call the first one PH and N here. And then we'll use A, B, and C. And we'll go like this. So are those two triangles congruent right now? Well, all the angles are, but do I know anything about the sides? I do not. So I would need to know something about the sides as well. So now that I have the sides, it's just supposed to be one dash there. Now that I know the sides and angles are congruent, are the triangles congruent? Heck yes, they are. And so now I can write triangle PHN is congruent to triangle. Okay, if I name the first one PHN, how do I have to name the second one? P matches up with what from down here? Angle P matches up with B. So PHN would be BCA. If I had named it triangle NPH, which would be fine. If I name it starting with N, then now I have to start with A. I went to P, P matches up with B, so this one would now be ABC. And so how you name this congruence statement over here, all right, means the corresponding parts need to match up. All right, so they're telling us here that triangle RSV is congruent to triangle TVS. So we need to solve for X and Y. Well, X is here in angle T. So the question is, do I know what angle R is? I should know that R is the first letter, T is the first letter, so T and R should be the same. Well, I know a triangle is 180, so I have inside the angles there, I have 90 plus 78 plus angle R equals 180. And so that's 168 plus angle R equals 180. And so angle R is 22. All right. And so if angle R is 22 and R is whatever T is, then I can just say here at the bottom, X equals 22. Now, when I go back to look at Y, Y is on side RS. RS, the first two letters, matches TV. TV is 24. And so I'm going to set that up as 2Y minus 1 equals 24. I add the 1 over. I divide by 2. I get Y equals 12.5. So I use my knowledge of what this congruent statement meant to step and solve problems. Third angle theorem. Third angle theorem. If I know two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent. The third angles are congruent. If two angles are already congruent to each other, then the third angles are congruent. Now let's talk about y's real quick. If this angle is, let's say this angle is 60. C is 60, that means K is 60. And let's say B is 40 here. That means J is 40. Well, how many degrees in a triangle? 180. And so these add to 100, so A here would have to be 80. These add to 100, so L here would have to be 80. So because they add up to the same number, and we already have two of the same numbers, the third numbers have to be the same. And so that's third angle theorem. It's extremely useful when you're doing proofs. All right, if you know two angles are congruent, the third angle automatically is. Very useful in proofs. Side note here, because it often gets confused, there is no such thing as a third side theorem or third side rule, only a third angle rule. And so they say this is using third angle theorem. I don't know that it really is, all right? But I know that these two angles down here are congruent to these two angles here. So angle L is congruent to angle S. So angle L, whatever L is, S is the same thing, right? And so either way, 90 plus 43 makes 133. 180 is the whole triangle, so I subtract them, right? And I get 47 degrees. Now, let's put this all together in the form of a proof, right? And so first things first, they have all of the stuff that's a given. I want to put all of that junk back in here. Angle J is congruent to angle P. JL is congruent to PL. JK is congruent to PM. And even L bisects KM. And now let's mark everything we said. So we said angle J is congruent to angle P. Well, they already marked that 1 to 1. And JL is congruent to PL. JL 2 ticks, PL 2 ticks. They got that marked. JK 1 tick, PM 1 tick. They got that marked. Right? And so now the last part of the given, right? I guess I should also write down that is the given. The last part of the given is this rule. L bisects KM. So what does that mean? That means the L splits KM in half. And so I can mark this half equal to this half. I'm using 3 tick marks because I've already used 1 tick mark and I've already used 2 tick marks. And so now I need to say that down here. So I want to say that. I want to say it would be KL is congruent to LM because that's what bisect meant. So it's definition of bisect. Now, to say the 2 triangles, because that's what I'm trying to prove, right? Down here, I am trying to prove the 2 triangles are congruent. That means I need 6 things. I need 3 sides congruent and 3 angles congruent. Right now, I have all the sides. I'm done with the sides. I only have 1 angle. I only have angle J is congruent to angle P. So then this is the next thing, and it's going to be the hard thing in the evolution of learning how to do proofs, is you have to just see some things. So when I see the picture, man, these lines crisscross. If lines crisscross, that creates vertical angles. And so with vertical angles, that means this angle right here and this angle right here are congruent. And so I need to aim. Now, I can't just say angle L because they're both angle L. So angle JLK is congruent to angle JLK PLM because of vertical angles. Now, if 2 angles are congruent to each other, I have P and J and L and L, all right, JLK and PLM. Then the third angles, in this case angle K and angle M, have to be congruent because of third angle theorem. And so I'm good on the third angles now. And so now I can say triangle JLK is congruent to triangle PLM. All right. And all 6 parts being congruent means all the parts are congruent. And I started with the definition of congruent polygons. If you said definition of congruent triangles, that would be fine. But if all the parts are congruent, then the polygons themselves are congruent. Okay. So let's break it down one last time here. What is the given? DE is congruent to GE. DF is congruent to GF. They mark those. Angle D is congruent to angle G. They mark that. DFE is congruent to GFE. They mark that. All right. And so they wrote down the given. They didn't write down the whole given at once. All right. Notice that. All right. So where is the rest of the given? Angle D is down here. So they split the given up. I usually don't do that, but it is allowed. All right. They're just splitting up the sides of the angles so they can think about it like that. All right. So I have 2 sides from the given. How do I know that third side is EF in both triangles? Yeah, it's right in the middle. It's in both triangles. Is EF equal to EF? Yeah, something's equal to itself. And what is that property? That is called the reflexive property. Way back when we first learned it, I said it was going to become important. And this is why. You're going to have them where they're joined together. And that means that you can write them as the same. And then the last one, if 2 angles are congruent to 2 angles, then the third angles are congruent. I just have to name them. I can't name them both E. So I'm going to go ahead and mark them here. I got this angle right here. and this angle on the other side. And so I want to name the one DEF, DEF, and the other GEF, GEF. And that is, again, third angles theorem. And then, again, I can say down here, definition of congruent polygons. If you said congruent triangles, that would be fine. These are the ones we are trying in our class. Go ahead and give them a try. Best of luck to you.